Hi students, welcome to another video on analog electronic circuits laboratory. So in the series of DC power supply design, so this is the fourth video. In this video we specifically see how to design a dual power supply. Okay, these are the prerequisites and these are some attentions to be maintained during the video watching. Okay, let us start the analysis. So we know that we can able to realize a DC voltage using two diode rectifier, that is fully rectifier, using, of course, the input voltage is a 230 volt 50 hertz AC signal. I will use uh, a center tap transformer. So this is the bridge, sorry, not the bridge, a two diode rectifier circuit. This is this. So this I will ground it. I will use a capacitor here to filter it, and I will use the regulator. I'll use the regulator 7805. So this is grounded. So here I'll get plus 5 volt. Here I'll get plus 5 volt. So here the requirement is I have to get plus 5 volt as well as minus 5 volt. So this is the requirement. So plus 5 volt as well as minus 5 volt. So I'm getting plus 5 volt. So assume that this you are using 909 volt as the regulator. So this is 909 regulator. Of course, we found that you can use a 240 microfarad as a capacitance value. So on, so you will get 5 volt. Then how do I get minus 5 volt? To get minus 5 volts, so what I'll do is I will reverse this diode. So I will use, so let me say this as D1, D2. Let me now use this. So this is, this on the, sorry, this is my diode. You can see this is, let me rewrite. So this is, so now I will short these two and I'll use it. So now I will connect this to this and this to this. I'm using the same transformer. You see, I'm using the same transformer, but I'm using the diodes in reverse direction. Let me say this as D3, D4, and I'll use a capacitor. Now I was getting a positive voltage here. Now I'll get a negative voltage. Since I'm getting a negative voltage, I will use a capacitor. Negative is a bit lesser value. I will use this as negative. This is now positive. So this is my positive value. Now I will ground this. This grounding is nothing but this point. So now what I'll do, I will take a wire from this. So this is that common ground point. So I'll just take it from here only. So it is this. You know, this ground both are same. So now I will use 7905. So this 7905 is, this is ground. So this is ground. So this is input, ground, output. This is minus 5 volt. This is minus 5 volt. See, this is, we know this is your plus 5 volt. So for negative 5 volts, so I'm using the same transformer. Can you see I'm using the same transformer? I'm using the same transformer, but the diodes are reverse. The diodes are reverse compared to this. So now you have to be very careful about the polarity of the capacitor. This is positive, this is negative. Negative means lower potential, and you know that this is 0 volt. This is some negative voltage. So 0 is more positive than negative. So that's why you're connecting plus here, minus here for the capacitor. It's again 240 microfarad capacitor. So now this is having a negative voltage. Negative voltage is regulated using 7905. You will going to get minus 5 volt. So you can able to get plus or minus 5 volt using two fully rectifiers using two diodes. Now assume that I want to get now can I able to realize the same four diodes using available bridge? We know that we have a bridge circuit. So bridge ICs are available. It is something like this. This is your bridge IC having 4 terminals. This is your bridge IC. So this is plus, this is minus. Now, if I name this as D1, if I name this as D, can you see here? This is, let me say this is anode. Okay, let me say this as D1. This is cathode. So if you name this as D1, this is anode. This is cathode. Correct? There is one more cathode connected. It is the same cathode connected. Let me say this as D2. Can you see this is cathode? This is anode. This is anode. This is cathode. This is anode. So where this should go? This should go to, let me connect the transformer. Let me connect the transformer here. So now I'm you connecting this here. So this will go there. Now does this, can you see, is this part, is this part realized using this part? Because there is a center tap. This center tap, I'll ground it. See now, I will use a capacitor. I will use a capacitor now. That is this capacitor. Let me say this as C1 or C positive. This is for C negative. This is C positive. So this is plus minus. This is grounded. Correct? So and then I will connect 787805, and this is also grounded here. So this is my 5 volt. Correct? So now this part is over. Can you see here? Is this negative? This is negative. That is cathode. And shall I say this as D3? Can you see this is cathode? Is this cathode connected to this? Can you see, is this D3 D1? Can you see this D3 D1? This is cathode, that is anode. Is it not this point? Is this point same as this point? So it is this. So then you have this terminal. This is this terminal. Can you see this is connected to cathode of D4, and the anode is shorted. This is this. So this is negative voltage. So I'll take this. I will use the capacitor. So capacitor, this is now, this is positive, this is negative. Can you see this is negative? I'm connecting this negative here. This is positive. So this is now again grounded. Can you see this is grounded? Positive is grounded. And then I have my regulator. This is 7905. This is input. The ground is grounded, and this is output. This is minus 1. So using a bridge, I can realize the same thing. So these two circuits are 100% same. This is a bridge circuit using center tap. Now this ground all are same. So what I need to do is when I indicate this is ground, they are actually shorted. They are actually shorted. That's what is the indication of same. So this is actually shorted. So in a bridge circuit, you will not be using the ground. For a dual power supply, which uses two diodes for positive voltage, another two diode for negative voltage, I am using the bridge circuit along with the center tap to realize plus 5 volt as well as minus 5 volt simultaneously. What I can do is I can also realize plus 12 and minus 12. How do I realize plus 12 minus 12? Instead of using 909, I will use 12 or 15 So then I'll be having larger voltage. So what I'll do, I will use 7812 and 7912 over here. So this is 12 volt regulator minus 12 volt regulator. I will give the input to this from the filter signal here. Can you see this is coming here? This is coming from here to this. This is again grounded. You can see you have a common ground. You extend that. This is ground. This is output. This is plus 12 volt. What I'm doing, this is a 7812 regulator. The input to this is the filtered output. Whatever that input you are giving to 7805, you get the same input to 7812. You'll get plus 12 volt. Of course, what should be the amplitude here? Amplitude should be more than around 15 or 16 volts. The peak, the minimum voltage should be more than this. So then you are going to get plus 12 volt. Again, this minus 12, how do you get? Again, you take from here the filtered signal, give it to this, and then this is your ground point, and this is minus 12. Can you see using the same power supply or same transformer, same 230 volt, 230 volt, 50 hertz AC signal, you are realizing plus 5 volt, plus 12 volt, minus 5 volt, minus 12 volt. So it is possible to realize plus or minus 5 and plus or minus 12 volt simultaneously using a single bridge circuit, using a center tap transformer, and of course using two filter capacitors. This is for C positive, this is for C negative, or to get positive voltage and negative voltage. Same thing is realized here. Here, this is a PCB that we have developed in the department. So this is developed in our department. See, there's a center tap transformer with 15015 as a rating. Can you see there is what filters? Sorry, a bridge circuit. Can you see this is sine wave and plus minus? The same thing is used. Can you see there is one positive voltage on negative capacitor, and this is 7812 or 7805. These are two positive, okay, one positive regulator, one negative regulator, one positive regulator, another negative regulator. So one is for plus 5, other is for plus 12, as one is for minus 5, other is for minus 12. So let me show you the voltages simultaneously. Okay, I will show you this. Okay, this is over here. So now I'm connecting the ground here. This is ground point. I'm just simply, we have given simply more number of ground points. And channel 1, let me see what's the voltage that I'm getting here. So let me see the voltage. Can you see I'm getting stages? This is plus 12, and see this is plus 5. So let me take on this average. So can you see one of the average? Let me just pick. Peak is typically 0 because we are looking at a rectified signal. Remove this, and let me remove this also for clarity. Now one is 5 volt, other is 12 volt. That is what I have here is, okay, so we have outputs. One is for plus 12, other is for plus 5. And you have simply we are having more number of ground points here. So let me just show you with more clarity. This is positive 12, positive 5 volts, and this is can you see this is minus 12 and this is minus 4. Can you see this is minus 5 and minus 12. So we are getting all four voltages, that is plus or minus 5 and plus or minus 12, using a single transformer, single bridge, 4 regulators, 7805, as we did it over here. What is that? This is circuit what we have. So this is circuit what we have. One transformer 15015. I'm using the center tap also, and you have the bridge circuit, and this is two capacitors. Can you see there are two capacitors, one for filtering the positive voltage, one for filtering the negative voltage. Of course, we have capacitors here also at the output of the regulator. We are connecting a ceramic capacitors here. So there are capacitors here also. These are ceramic capacitors of 0.1 microfarad. That's what is this. Each regulator output has got one capacitor each. And this is the PCB developed by one of our students. So this is the circuit. So whatever circuit we have, that is being put as made as a PCB. So this is how you can able to realize a dual power supply. Okay, thank you.